Welcome to the SmartKeys podcast. Imagine strapping on a harness, walking up to a heavy, awkwardly shaped piece of machinery, and reaching down to lift it.
Right.
But instead of that familiar, dread-inducing jolt of strain hitting your lower back, you feel this subtle mechanical lift taking the weight for you.
Yeah, doing the work.
Exactly. A 50-pound load suddenly feels like a feather. Now, we usually picture industrial innovation as, dark, fully automated warehouses where robots have entirely replaced human beings.
Oh, 100%. Just machines everywhere.
Right. But what if the real revolution isn't about replacing the human worker, but upgrading them?
That's the real question.
Just to set the stage for you today, we are looking at a problem with a massive, almost incomprehensible scale in modern industry. We are talking about roughly 4.5 million overexertion injuries.
Yeah, that number is staggering.
And well over 100 million lost production days every single year, and that's in the U.S. alone.
Just math.
And this is all directly tied to things like lifting, repetitive tasks, and sustained overhead work. So today, we are bringing you a deep dive into this incredibly detailed article by Felix Römer from SmartKeys.org. It's titled Exoskeletons in the Workforce: Augmenting Human Labor in Industry.
This is a fantastic piece.
It really is. And our mission for this deep dive is to treat this source material as a strategic playbook for you, the modern professional.
Yeah, a real practical guide.
Because this is not science fiction or some, distant futuristic concept. We are talking about practical business efficiency, risk management, and the literal future of work.
What's fascinating here is how the conversation around exoskeleton technology has completely shifted over the last few years.
Oh, totally.
Because for a long time, it felt like a novelty. You'd see a prototype at a trade show, and it looked like something out of a comic book, right?
Yeah, like Iron Man or something.
Exactly. Clunky, experimental, and just wildly expensive.
Yeah.
But as this article so clearly lays out, we have moved far beyond the novelty phase.
Right.
We are now dealing with highly targeted, deeply measurable, wearable technology. It's become this strategic tool that directly addresses occupational safety, actively mitigates those massive injury statistics you just mentioned, and, well, ultimately protects the company's bottom line.
Which is what leadership cares about.
Exactly. The entire philosophy has pivoted toward optimizing the human body for the punishing environments we've built, rather than just hoping human cartilage and muscle hold up over a 30-year career.
Which, spoiler alert, they usually don't.
No, they definitely don't.
So before a business can even think about implementing these solutions, you really need to understand the tools that are actually on the table. We have to decode the gear.
Right, getting into the hardware.
Because the article makes a very firm distinction between passive and active systems, but I want to get into the mechanics of this. Can you break down the actual hardware available on the market right now?
Yeah, absolutely.
Because if I'm a facility manager, I need to know how a piece of equipment without a battery is supposed to help someone lift a heavy crate.
Well, the foundational split in the market is indeed between passive and active support devices. And understanding the biomechanics of how they operate is critical for any operational leader who is planning a rollout.
Okay, so let's start with passive.
Let's tackle passive systems first. The defining characteristic of a passive exoskeleton is that it operates entirely without batteries, motors, or digital actuators.
Nothing to plug in.
Right, no charging cables at all. Instead, it relies on advanced materials, specifically springs, elastic elements, and mechanical linkages.
Okay.
To understand how it works, you really have to look at how human muscles perform under a load. When a worker bends down to pick something up, their muscles lengthen under tension.
Makes sense.
The passive exoskeleton's elastic elements stretch right alongside the body, effectively capturing and storing that kinetic energy.
Oh, I see.
Then, when the worker stands back up, those springs contract, returning the stored energy to assist the movement. It literally offloads the physical work from the worker's lumbar spine to the external mechanical frame.
Okay, let's unpack this. So it is essentially using the worker's own physical movement to create a dedicated support system.
That's a perfect way to put it.
I like to think of a passive exoskeleton kind of like a car's advanced suspension system.
Oh yeah, that's a great analogy.
Because the suspension doesn't drive the car, right? And it certainly doesn't do the work of the engine for you. But it absorbs the immense physical shock of the road, which in this case is the strain of repetitive daily tasks.
Exactly.
And by absorbing that shock, the engine, meaning the worker's own musculoskeletal system, doesn't wear out nearly as fast.
I love that. Taking that car suspension idea further, The major operational advantage of that design is longevity and simplicity.
Because there's no battery to die halfway through a shift.
Precisely. Because passive systems don't require heavy lithium-ion batteries or charging stations, they are remarkably lightweight and require significantly less maintenance.
Which is huge for a busy warehouse.
Oh, massive. The article actually highlights some proven, widely adopted models in this category. For instance, the Exobionics Exo EVO.
I saw that one in the text.
Yeah, the engineering focus of that specific model is on large armholes and minimal bodily touch points.
Why does that matter?
It matters because it allows for natural motion tracking. It doesn't restrict the worker's natural proprioception or fight against their organic movement during, say, complex overhead assembly.
So they don't feel like a robot locked into a track.
Exactly. They still have their full range of motion. Then we see the IX series. The IX Back Air provides non-electric mechanical spinal relief.
Oh, wow.
Yeah, it physically guides a safer posture during lifts and bends. And for workers doing sustained overhead work like mechanics or assembly line painters, there is the IX Shoulder Air.
Which I imagine is a lifesaver.
Truly, it utilizes the body's own motion to counterbalance gravity, vastly easing the strain of keeping your arms elevated for long, grueling periods.
But those passive springs can only do so much, right?
Well, yes.
Like if a worker is dealing with unpredictable weights or suddenly needs to lift something much heavier than the springs are calibrated for, that suspension system might bottom out.
Exactly, it has its limits.
So that brings us to the other side of the spectrum, the active systems.
Which is where we introduce the heavy-duty tech. Active systems integrate motors, batteries, and sensor networks.
The real cyborg stuff.
Exactly, yeah. They are actively analyzing the environment and providing powered variable assistance. An operations manager would choose an active system when dealing with highly variable loads or intensely heavy lifting, where human muscle simply needs an external power boost.
Right.
The necessary trade-off, though, is that these suits are heavier, they require strict battery management protocols, and they need regular software updates.
Just another thing for IT to manage, right?
You're not wrong. But the article specifically calls out the IX BIC Volton as a prime example of modern active gear.
Okay, the Volton.
Yeah, and what makes the Volton notable is its integration with the Bosch AmpShare battery system.
Oh, wait, so it just uses standard tool battery.
Exactly. From a facility management perspective, standardization is everything. You don't want a warehouse juggling 50 different proprietary chargers.
No, that would be a nightmare.
Utilizing a universal battery system like Bosch AmpShare allows these active exoskeletons to draw power from the same batteries a crew might already be using for their power drills, drastically lowering the barrier to entry for intense lifting environments.
Okay, here's where it gets really interesting, though. We are talking about springs, straps, and motors, but this technology is no longer just physical hardware.
Right.
There is a deeply integrated digital layer being laid over this physical tech that, honestly, changes the entire conversation.
Oh, the software side is huge. The integration of software and digital health tools is the tipping point where this gear transforms from a simple physical aid into a comprehensive workforce management system.
Okay.
The text points directly to digital wearables and software accessories, like the ARGO XP and the CX series.
So what do those actually do?
Well, these platforms aren't just sending a ping to a dashboard to verify the device is turned on. They are actively tracking nuanced data. Things like time in task, dynamic usage patterns, and crucially, early discomfort trends based on how the worker's movement profile changes over a shift.
Hold on, let's clarify that term time and task. If I'm looking at a dashboard, what am I actually seeing? Am I just acting as Big Brother monitoring how fast they are working?
That's the fear. Right. But no, it is not about monitoring speed. It is about monitoring physical vulnerability.
Okay.
The dashboard shows a facility manager the actual aggregated physical load the team is bearing and how long they are sustaining risky postures.
So it's looking for danger zones.
Exactly. If the data shows a sudden spike in awkward movements or a degradation in posture during a specific afternoon shift, management can intervene.
Wow.
Yeah, they could rotate the crew or adjust the workflow before that subtle fatigue turns into a reported catastrophic injury. It moves occupational safety entirely from a reactive protocol to a proactive strategy.
Which is a brilliant pivot into our next area, because connecting this highly sophisticated, data-driven tech to the gritty reality of the shop floor brings up a massive new set of challenges.
It definitely does.
Because the best hardware in the world, backed by the best software, is completely useless if the workers absolutely refuse to put it on.
That is the truth. The implementation phase is where most technology deployments live or die. The human element is vastly more complex than the engineering.
So I am going to jump in and play devil's advocate for a minute.
Go for it.
If I am a worker on an assembly line and corporate management comes down handing out these robotic harnesses, my first thought is not, oh, they care about my lower back.
Nope.
My first thought is that the company just wants me to be a cyborg. I'm going to assume they want to augment my body specifically so they can push me to work 20% faster, lift heavier things, and basically squeeze more productivity out of me until I break.
Yeah, that's incredibly common.
How does a company actually overcome that level of deeply ingrained natural cynicism?
Well, that cynicism is entirely justified based on the history of industrial labor, and it raises an important question that the article addresses head-on.
Okay.
Building trust is the absolute foundation of exoskeleton change management. A leadership team must be crystal clear about their intent from day one.
Communication is key.
Exactly. The stated, documented, and practiced goal must be to reduce physical effort and fatigue, period. It cannot be used as an excuse to speed up work or increase quotas at the expense of safety.
Because the workers will see right through that.
Instantly. If workers feel the exoskeleton is just a tool to extract more labor per hour, adoption will fail catastrophically. The messaging, backed up by management's actions, has to be, we want you to go home at the end of the day with enough energy to play with your kids, rather than nursing a sore shoulder.
Proving that intent requires a lot of on-the-ground collaboration, I'd imagine. And beyond the psychological trust, the text highlights some very real physical barriers to adoption. Things that might sound like minor inconveniences in an air-conditioned boardroom, but are absolute deal breakers on a sweltering factory floor.
Oh, absolutely. The article categorizes these physical hurdles into three major areas: thermal burden, pressure points, and PPE compatibility.
Let's talk about thermal burden first.
It's arguably the most immediate challenge. You are strapping a robust piece of equipment tightly to a human body. In a non-climate controlled warehouse or on an active construction site in July, the heat buildup under the device's padding can make it unbearable within an hour.
Yeah, no one is wearing that.
Right. Then you have to account for pressure points or hot spots. If a harness rubs aggressively against the collarbone, or if the arm supports restrict a worker's fine motor skills during delicate assembly, they will simply take it off and leave it in their locker.
And the PPE compatibility, I hadn't even considered that angle until I read the source material.
It's a huge blind spot for lots of managers.
Like if the exoskeleton's back frame interferes with a worker's required fall arrest harness, or if the shoulder straps push up against their safety glasses or hard hat, it's a non-starter.
Exactly.
Basic safety compliance is always going to win that battle.
Which is exactly why the article strongly advises running short, iterative, heavily monitored fitting sessions. You have to rotate sizes and adjust straps continuously during the pilot phase so those hot spots and equipment conflicts are resolved before the worker forms a negative opinion of the gear.
You only get one first impression.
Exactly. But even if you solve the heat and the fit, you still have to navigate the deeply ingrained social and psychological aspect of manual labor.
Yeah.
Workers often judge new gear by how it impacts their identity and their pride in their craft.
I can completely see that. Nobody wants to feel like they're being treated as fragile, or that they suddenly need a medical crutch to do a job they've been executing flawlessly and proudly for 20 years.
Yes, the framing of the rollout is critical to bypassing that stigma. The gear must be positioned internally as a smart tool that protects their physical capability and longevity, rather than a replacement for their skill or a remedy for weakness.
Oh, that's a great way to pitch it.
It is fundamentally no different than a company providing a high-quality, vibration-dampening ergonomic power drill instead of a cheap manual screwdriver. Both get the job done, but one protects the worker's joints.
Right.
And a massive part of winning that social acceptance comes down to granting the worker autonomy.
You mean letting the crews choose when and where to actually deploy the tool?
Exactly. The text strongly advocates for establishing specific wear windows.
Okay, wear windows.
Yeah, instead of mandating that a worker strap into the device for a grueling, mandatory 10-hour shift, you allow crews to deploy the gear during targeted tasks. They might choose to wear it only during the peak lifting times of the shift, or maybe only during the cooler morning hours to manage the thermal burden.
That makes so much sense.
You place the autonomy directly in the hands of the end user. When peers and supervisors respect that autonomy and treat the device as a supplemental smart tool rather than a uniform requirement, voluntary buy-in increases dramatically.
Okay, so let's say we've successfully navigated the mechanical hardware choices, and we've managed the complex psychology of the shop floor. Eventually, this entire project has to land on the desk of the CFO.
Always does.
We are moving from worker acceptance to leadership justification. How does a business actually measure the success of these devices to build a bulletproof ROI case? Because rolling out a fleet of exoskeletons is a significant capital investment.
It is. But why this matters from a strategic boardroom perspective is fundamentally about operational consistency and severe risk mitigation.
Okay.
The technology specifically targets and reduces the mechanical load on the lumbar muscles during repetitive lifting, and the deltoids and trapezius muscles during sustained overhead work.
Which are the areas most prone to injury?
Exactly. By objectively lowering that daily physical toll, companies drastically cut their injury-related costs down the line. We are talking about reducing the frequency of on-site first aid visits, cutting down on expensive workers' compensation claims, and drastically lowering the number of lost time days.
Wow.
And the crucial factor for the CFO is that all of this cost reduction happens while keeping baseline productivity completely steady. In today's highly competitive labor market, retaining a skilled, healthy, and experienced worker is a massive competitive advantage.
Yeah, because the actual financial cost of recruiting, hiring, and training a replacement because your senior technician blew out their shoulder is astronomical compared to the upfront cost of deploying a passive shoulder support system.
It's not even close.
And the article provides some incredibly robust, real-world evidence to back this up. Let's look closely at the IKEA deployment.
Oh, the IKEA case study serves as a perfect benchmark for enterprise-level scaling.
I mean, they deployed over 400 exoskeletons across 14 different countries.
It's massive.
Their operational focus was specifically targeted at their global logistics network, aiming to ease the daily, relentless burden of lifting and case handling in their massive warehouses and retail stores.
Right, and purchasing and deploying 400 units is a serious strategic commitment.
Yeah.
That isn't just a small pilot program to test the waters.
Yeah, that shows real faith in the tech.
It demonstrates deep institutional belief, and the results validated that investment. By analyzing the wear data, IKEA saw their logistics crews sustaining their baseline activity levels with significantly fewer fatigue complaints during their absolute peak, most physically demanding shifts.
Wow.
Yeah, and when the aggregate fatigue of a warehouse crew drops, the error rate drops, and subsequent injuries drop.
That's huge. And then there is the man, truck, and bus case study, which took a slightly different angle on deployment.
Yes, a more targeted approach.
They rolled out over 50 shoulder devices and 25 back devices across 20 of their regional maintenance locations. But the defining detail the text points out is how they handled the human element. They paired the technology rollout directly with personalized on-site ergonomics expert training.
That combination is vital for long-term success. An exoskeleton is not a magic bullet that fixes bad habits. It supplements and enhances safe working methods.
You can still lift wrong while wearing one.
Exactly. By combining the physical gear with professional ergonomic coaching, man, truck, and bus successfully cut physical strain during those notoriously awkward, sustained overhead repairs, like working underneath a commercial truck chassis, which are a primary driver of chronic shoulder deterioration.
It's clearly catching on across various sectors, too. The article notes that massive industry heavyweights like Toyota, Boeing, and DB Schenker are all actively utilizing and studying this tech.
Industry leaders are definitely paying attention.
Yeah, DB Schenker is even taking it a step further, exploring the formalization of these exoskeleton units as standard personal protective equipment, or PPE, for specific high-strain tasks.
That's fascinating.
It represents a massive paradigm shift in how we view workplace safety gear.
It really completely redefines the concept of PPE. Historically, we have viewed PPE as a shield against acute sudden accidents, like a hard hat protecting against a falling wrench, or steel-toed boots protecting against a dropped pallet.
Right.
Exoskeletons move PPE into the realm of protecting against chronic, cumulative, invisible damage over time. But to get a company to that level of adoption, the article gives very clear, actionable advice on how to structure a pilot program.
Which is exactly what our listeners need.
Right. If you are a listener planning a rollout in your facility, you must track specific, objective metrics before you attempt to scale.
Because you can't just hand 50 units to the floor managers, wait a month, and ask the crew, so, how do you feel? You need a data-driven baseline.
Yes, exactly. A rigorous pilot relies on specific data pillars. First, you track task cycle time to ensure the device isn't inadvertently slowing the workflow down or restricting movement.
Okay.
Second, you measure perceived exertion. This is often tracked using the Borg RPE scale, or rate of perceived exertion. While RPE is a subjective measure from the worker, when you aggregate that feedback across dozens of shifts, it becomes a highly reliable statistical tool for mapping fatigue.
Makes sense.
Third, you closely track device wear time to gauge actual voluntary adoption rates.
If they aren't wearing it, it isn't working.
Exactly. And finally, you track the hard safety metrics, near-miss rates, and first aid events. You build your bulletproof ROI case for the CFO by combining those expected reductions in long-term injury costs with the immediate productivity gains of a workforce that isn't burning out by 3 in the afternoon.
So, what does this all mean for the horizon of industrial labor? We've looked deeply at the current hardware, the complex shop floor psychology, and the boardroom ROI. Let's shift our focus to what the future holds for modern professionals. Where is this technology actually heading in the next 5 to 10 years?
Well, the forward-looking insights embedded in the text point to a few massive evolutionary leaps. First, the physical materials are going to become exponentially lighter and significantly more breathable,
Addressing those thermal issues.
directly attacking the thermal burden and hotspot issues we discussed earlier, making all-day wear much more realistic. Second, we will see a much tighter, seamless integration with those digital health platforms.
Building on the ARGOXP systems we talked about earlier, where the suit is talking to the management dashboard.
Right, but taking it far beyond basic reporting. The shift in R&D is heavily leaning towards systems that provide real-time, data-driven coaching. The next generation of devices won't just track the strain after it happens, they will predict it. The software will analyze a worker's micro-movements and alert them, or their supervisor, that a specific lifting pattern is trending toward a severe musculoskeletal injury.
That's crazy.
It allows a facility to adjust the workflow and correct the posture before a muscle is ever torn. We're moving rapidly from passive physical support to highly intelligent, predictive ergonomics.
That level of predictive safety is incredible. Okay, I want to distill all of this down to a practical, step-by-step action plan for you, our listener. If you are looking to bring this technology into your business operations, here is your playbook based on everything we've covered today.
Let's hear it.
Step 1, start small. Do not order 500 units on day 1 and force them onto the floor. Step 2, pick highly repeatable, high-load tasks for your pilot. Look for areas in your facility with steady overhead fastening or constant predictable lifting.
Good advice.
Step 3, relentlessly confirm the fit and ensure the gear plays nicely with your existing mandatory PPE. And finally, step 4, scale the program only where your data shows fewer injuries and clear voluntary worker buy-in. It has to be a collaborative effort between management and the floor.
If we connect this to the bigger picture, this entire evolution raises an incredibly profound question that I think every modern business leader needs to ponder.
What's that?
We inherently think of a company's tech stack in terms of software licenses, cloud computing architecture, and AI algorithms.
Right.
But as these advanced digital wearables and physical passive supports merge into a single ecosystem, the very definition of a corporate tech stack is changing.
Yeah.
What happens to the market when a company's biggest competitive advantage isn't just their proprietary software, but the augmented physical longevity of their human workforce?
Wow.
How will the ability to physically upgrade a worker entirely redefine what we consider human resources in the next decade?
That is such a wild perspective-shifting thought. We spend millions of dollars cooling and optimizing our server racks so they don't crash under a heavy load, but we are only just now realizing we can actively optimize our human infrastructure so they don't break down under a heavy load either.
Precisely.
A medical X-ray might clearly show the broken bone or the torn rotator cuff, but this technology is fundamentally trying to make sure you never have to take that X-ray in the first place.
Exactly.
Thank you for tuning in to the SmartKeys podcast. We hope this deep dive gave you some serious, actionable, strategic insights into the rapidly approaching future of augmented human labor. Please make sure to subscribe to the podcast so you never miss an update on the future of work, operational strategy, and business efficiency. And we strongly encourage you to explore the source material yourself and read Felix Römer's full comprehensive article. The link to the original SmartKeys article can be found right in the show notes. Until next time, keep looking forward.